Today, we're going to look at a trinomial square, which is an expression with three terms inside parentheses raised to the power of 2. Here we have a plus b plus c, all squared. Let's focus on this exponent 2. When we see a squared term like this, it's telling us to multiply the entire expression by itself once. So we can rewrite a plus b plus c squared as a plus b plus c multiplied by a plus b plus c. This is exactly what the exponent 2 means, to use the expression as a factor twice. Notice that both factors are identical. We're literally taking the original trinomial and multiplying it by itself, just as we would when squaring a number like 5 squared equals 5 times 5. This relationship between a trinomial squared and the product of two identical trinomials is a key algebraic identity that appears frequently in mathematics. While this form helps us understand what squaring means, we'll need to use the distributive property to fully expand this expression and collect like terms. Now that we understand that a plus b plus c squared means multiplying a plus b plus c by itself, we're ready to see what happens when we actually perform this multiplication. Let's explore how to expand the trinomial square, a plus b plus c squared. This is similar to expanding a binomial square, but with 3 terms instead of 2. Remember that any expression squared means the expression multiplied by itself, so we can rewrite a plus b plus c squared as a plus b plus c multiplied by a plus b plus c. To apply the distributive property systematically, we'll set up the first factor on the left and the second factor on top. This visual arrangement will help us keep track of all the multiplications we need to perform. When distributing with trinomials, we need to multiply each term in the first factor by each term in the second factor. To organize this, we'll create a 3x3 grid with 3 rows for the terms in the first factor and 3 columns for the terms in the second factor. We'll label each row with a term from our first factor, a, b, and c, and we'll label each column with a term from our second factor, also a, b, and c. This grid helps us ensure we don't miss any multiplications when applying the distributive property. Let's identify the individual terms in our first factor and connect them to the corresponding rows in our grid. The a term will correspond to the first row, b to the second row, and c to the third row. Similarly, let's identify the terms in our second factor and connect them to the corresponding columns. The a term will correspond to the first column, b to the second column, and c to the third column.